Hey guys, today we're going to do a quick video on multiplying and dividing polynomials. So this would be in grade 9 curriculum, unit 6 I believe. And we're going to look at two examples where we multiply through the numerator and then divide by a monomial in the denominator. Again, explicitly highlighting the importance of remembering first of all, our negatives all the time and our exponent laws. Our exponent laws are so easy to forget when we're multiplying through by polynomials. And so I just wanted to reiterate the importance of always being careful with that. So for number one, let's simplify through our numerator first, and then we'll deal with the denominator at the end. And so if we use our distributivity property, we're going to multiply each term individually by the monomial up front. A monomial is simply a mathematical term for a polynomial with one term only, and so that 4x cubed is exactly that. Okay? So we're going to start off with 4x cubed times our first term inside the brackets of negative 3x squared. Okay, so 4 times negative 3, let's not forget, is negative 12. And then our exponent rules state that x to the power of a times x to the power of b becomes x to the power of a plus b. Right? One of the first exponent laws you would have learned. And so x cubed times x squared produces an x to the power of 5. Okay, that's our first term. Next up, we have 4x cubed times 5x. And so 4 times 5 gives a coefficient of 20. And then applying that same exponent law, x cubed times x. Remember, x with no exponent is implied that we have an x to the power of 1. And so if we add the two exponents, as the rule would tell us to, 3 plus 1 gives us an x to the power of 4. Okay. And then in the end, there's no x in the last term, and so we'll just have the x cubed that we already have up front. So 4 times negative 10 is negative 40, and then let's not forget to tack on the x cubed, okay? Always over 2x. And now, to finish that off, I'll remind you of our second exponent law that you most likely would have been taught in grade 9. That is, when we divide by the same base, we subtract the exponents. And so if we have x to the power of a divided by x to the power of b, we can write this simplified as a to the power of a minus b, subtracting the two exponents, okay? And so again, the 2x on the bottom, I'll remind you, acts as the 2x to the power of 1, okay? And so applying this rule, negative 12 divided by 2 is negative 6. And then x to the 5 divided by x to the 1, we subtract the exponents. And so 5 minus 1 gives us an x to the power of 4. Okay. Next up, we have the 20x to the power of 4 term divided by 2x to the 1. 20 divided by 2 is positive 10. And then x to the 4th divided by x to the 1 leaves us an x cubed term. And finally, negative 40 divided by 2, negative 20, x cubed divided by x leaves us with an x squared term. And there we have it, okay? So, a 2-in-1 application of our exponent laws, being careful with our negatives, each term one at a time, and there we go, okay? The second one is going to be very similar. We're going to divide by a monomial that is simply raised to the third power, but the same rules apply, okay? And so let's multiply through with our distributivity property. And so we're going to start off negative 6y to the 4 times 5y squared, remembering that when we multiply through by the same base, that is the same base of being y, we add the exponents. And so negative 6 times 5 starts us off with negative 30, y to the 4 times y to the 2 times y to the 6th, right? Next, we have negative 6 times negative y. A negative times a negative, let's not forget, produces a positive product. And 6 times, there's no coefficient in front of the y, so we imply that there's a 1 there. And so we'll simply have 6. And so y to the 4th times y, again, there's no exponent, so it's implied that there's a 1. 4 plus 1, adding the exponents together, produces a y to the 5. And finally, negative 6 times negative 4, negative times a negative, again produces a positive product. And this time we have y to the 4, there's no more y attached to the third term inside the bracket, and so all we get is a y to the 4, okay? Again, all over our denominator of 3y cubed. And finally, now we can divide through each term by our denominator of 3y cubed, and so going one term at a time, negative 30 divided by positive 3 produces a quotient of negative 10, and y to the 6 divided by y to the 3, using our second exponent rule that we have here, we subtract the exponents, and 6 minus 3 gives us a y cubed term, okay? Next up we have plus 6 divided by 3 is 2. Both coefficients are positive, and so plus 2. Y to the 5 divided by y to the 3, subtract the exponents, becomes y squared. And finally, 24 divided by 3 is 8. And y to the 4 divided by y to the 3, we subtract the exponents, and so 4 minus 3 gives us a measly y. And that's that. So here is our simplified version of our polynomials or rational polynomials since they're in fraction form. So I hope this helps. If you guys have any comments, questions, please leave a comment down below. And as always, any requests for future videos. Thanks for watching.